Today we're going to talk about fractions, okay? Specifically, we're going to talk about adding and subtracting fractions. Before we get to that, let's talk about what a fraction is. A fraction, like 1/2 or 3/4, is written like this, okay? The top number, the number on top of the fraction, is what we call the numerator, and the bottom number is called the denominator. Okay? The denominator tells us how many pieces the whole is cut into. How many pieces are in a whole? The numerator tells us how many pieces we have. Okay? Now, when we're adding and subtracting fractions, it's only fair that we add and subtract, right? It's like we're exchanging pieces, and we're only going to be able to exchange equal pieces. It would be like, if they weren't equal pieces, it would be like me having a quarter and you having a dime and me saying, well, we're just going to change pieces. So now I have a quarter and you have a dime. I don't think that's a fair trade, right? Because the quarter is worth more than the dime. So we need first to be able to think of things in equal pieces. So let's first represent 1/2 as a picture. So I'm going to try to draw these pictures so that they look the same size. They don't have to be square. It's easier for me to make squares. So 1/2 means I have a whole, which I do here, cut in two pieces, two equal pieces, and 1/2 means that basically I have one out of those two equal pieces. All right, so 3/4 as a picture, if I try to make my box about the same size. So I have the same whole, but this time it's cut into 4 equal pieces. My denominator is 4. 3/4 means that I have 1, 2, 3 pieces. Okay? So that's what they represent. So the number on the top is the number of pieces that we have to work with, and the bottom number is the number of pieces that the whole is cut into. So let's start out with a simple addition. Let's do 1/4 plus 1/3. Okay, so let's represent these as pictures. All right, so I'm going to try to be consistent here with my sizes. So 1/4 means I have a whole cut into 4 pieces, and I have 1 piece. 1/3 means I have a whole cut into 3 pieces, so I'll cut it this way. I could have cut it the other direction as well. And I have 1 out of 3 pieces. Right? So if I wanted to add these together, right, when we add and subtract things, we only talk about the same number of pieces. I wouldn't say that I had 2 out of 7 pieces, which, I mean, technically, in this picture, I do have 2 out of 7 pieces, but when we talk about a denominator of a fraction, we talk about the same size pieces, and we don't have the same size pieces. So before we can exchange them or add them together, we need to first cut them into the same sizes. So we have 4 pieces over here and 3 pieces over here. So what I'm going to do with the fourths is I'm going to cut each fourth into 3 equal pieces. Now these are small pieces. We'll pretend that they're equal. So my new whole has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. Now my 1/4 covers up 1, 2, 3 of those pieces. So 1/4 and 3/12, right? These are what we call equivalent fractions. The whole is cut into different pieces, but we have the same proportion of pieces. We can also get equivalent fractions. I mean, we can see the picture here, but you can also tell that if I multiplied 1/4 times 3 over 3, where 1 times 3 is 3 and 4 times 3 is 12, that's another way that we can also come up with equivalent fractions. So since I broke the fourths into each one into 3 pieces, I'm going to this time take the thirds and break them into 4 equal pieces each. That should also give me 12. So there's 4, 4, 4. So again, I have 12 as my denominator because now I have a whole that's cut into 12 pieces, and my 1/3 is 1, 2, 3, 4 of those pieces. Okay? So now when I add these two together, right, I definitely have a whole that's still cut into 12 pieces. The number of pieces that my whole's cut into doesn't change. It's just a number of pieces that I have total. So if I had 3 of these 12 pieces on this side and 4 of the 12 pieces on this side, I now have 1, 2, 3, 4, 5, 6, 7 out of 12 pieces total. So that's how we add 1/4 plus 1/3. So what you hear saying as the common denominator basically just means that both of our whole pieces need to be cut into the same number of pieces. Okay, so let's move on to another one. Let's do, this time, 1/2 plus 3/4. Okay, so let's draw some pictures here. A half means I have 1 out of 2 pieces plus 3/4. That means I have 1, 2, 3 pieces over here. Now with 1/2 and 3/4, I don't actually have to cut both of these into new pieces because I can easily take this 1/2 and split it one more time, and now it has 4 pieces too. My 1/2 as fourths is the same as I have 2 sides that are shaded over here is 2/4. Plus then I have 3/4 over here, right? I didn't have to change that at all. So my number of pieces in my whole didn't change. It's still 4, but now I have 1, 2, 3, 4, 5 pieces. So this time I have 5/4. That means when my numerator is actually larger than my denominator, it means that I have actually more pieces than what make up a whole, right? So it's kind of easy to see that if I have these 3 and I move this one over here, right, then I would have this one whole pie would be picked, this one square would be filled in, plus then I'd have 1 left over. So I actually have more pieces than I have a whole, but we still, that's the way a fraction is defined, is that the bottom number is the number of pieces in a whole that we have. So 5/4 means that I have more than a fourth, or more than a whole one. So I could also write this as 1 whole plus 1 out of 4 other pieces. Okay, so let's try one more addition. Let's do 1/3 plus 2/5. Okay, so 1/3, I have 1 out of 3 pieces. 2/5. Okay, so this time I'm going to try to cut 1, 2, 3, 4. They're a little off, but let's try to draw that again. Okay, so we'll just kind of imagine that those are 5 equal pieces. Okay, so 2/5 would be this one and this one. All right, so we need to be able to cut these into the same size pieces. Okay. So one easy way to do it is we'll cut the 3's into, because my denominator is 5, we'll cut each one of these into 5 pieces. So there's 1, 2, 3. Ooh, that's bad. I did a very bad job. But 1, 2, 3, 4, 5. We'll pretend like those are all equal pieces. So in the end I have 1, 2, 3, 4, 5 times 3, which is 15. So I have 1, 2, 3, 4, 5 in the shaded area. So 1/3 is the same as 5 over 15. Right? If I took this and multiplied 1 times 5, I'd get 5. 3 times 5 is also 15. That's how I get this number here. All right? So over here I'm going to cut each one of these into 3. This is a little bit easier. So there's 3 pieces. Again, I have 1, 2, 3, 4, 5 and 3 rows of them. So I'm going to have 15 pieces total. This time I have 1, 2, 3, 4, 5, 6 pieces. Again, if I multiplied 2 times 3, I'd get the 6, and the 5 times 3, I'd get the 15. So now I have these two, what we call equivalent, 1/3 and 5/15 is equivalent to 2/5, and 2/5 and 6/15 are also equivalent. So now when I add them together, right, I have a certain number of 15ths that I have, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 15ths total. Okay, so now that we've sort of mastered addition, let's move on to some subtraction problems. Alright, so let's start out with 3/4 minus 1/8. Okay, again, when, whether I'm adding or subtracting, I'm basically giving and taking pieces, right? When I'm adding, it's like I have some and you have some and we're putting them together. When we're subtracting, maybe I have this many and I'm going to give you some of mine. So now I'll have less of them. So 3/4, again, let's draw a picture. 3/4 means I have 3 out of these 4 pieces. And then if I have 1/8, so I'll cut this into 4, and then I'm going to cut each one of these pieces into a half as well. So 1/8 is smaller. Okay. So now, again, I need, in order to be able to find out, technically speaking, I have 1, 2, 3, 4 pieces out of a total of 12 pieces, but when we're talking about fractions and subtraction, we're talking about equal pieces. So I need to cut them into equal pieces. Now it's really easy for me to change these fourths into 8 by just cutting each one of these in half again. So now I have 8 pieces in my whole, and now it's 1, 2, 3, 4, 5, 6 of those pieces, 6/8. And then I have minus 1/8. I haven't done anything with that. So if I had 6 to begin with and I take away 1, basically I'm going to take away this piece here. I have 1, 2, 3, 4, 5 of them, right? Just 6 minus 1, and I end up with 5/8. Okay, how about if we do 5/6 minus 1/2? So I'm going to draw my pictures here. So I'm going to cut this in half, and then I'm going to cut these into 3 pieces, giving me 6 equal pieces. There's my half. So 5/6 would be 1, 2, 3, 4, 5. And a half would be this piece. So, right, the half is really nice and easy to I can easily cut this one into 6 by just cutting it the same way that I cut the other piece. So 1/2 is the same thing as 3/6. Okay, I can also think of this like this, multiplying 1/2. 1 times 3 is 3, 2 times 3 is 6, and there I have my equivalent fractions. So I have 5/6 minus 3/6. So if I take away 3, that's this one, and this one. That leaves me with the 2 that I have left over of 6. Now if I draw my picture in a different way, 2/6 I can actually simplify down, right? If I think of these two as my 2/6, and what if I just took away, what if I didn't split this in half here and here, right? I really have 3 equal pieces, so this would be the same as 1/3. So 2/6 and 1/3 are the same equivalent fractions. It's just that this piece is broken into 6 pieces and I have 2 of them. This one is broken into 3 and I have 1 of them. But it's still the same proportion of the whole itself. Also, if you think, I could multiply this by 2 and this by 2, and I would get the 2/6. Alright, that concludes my demonstration on fractions and adding and subtracting. So I hope this helps.